Okay, I know the paper says H8B Part 2 sinusoidal models, but next year it's going to say H8B Part 3 unit circle and trigonometric identities. Okay, so in our last lesson we made the unit circle. Okay, and we talked about how going all the way around the circle is 360 degrees, and going all the way around the circle is 2 pi, and so half of the unit circle is pi, a quarter of the unit circle is pi over 2, and so on. 30 degrees is equivalent to pi over 6, and we went through this whole process of how to get these various angle measurements in degrees and in radians. Okay, so in this chapter we've talked about the right angles. So you've learned long ago, TOA, right? So we know that sine of an angle is equal to opposite over the hypotenuse, right? But what if the hypotenuse is 1? Then I would have sine of an angle is equal to just the opposite, right? Because if this is 1, it's just, over 1, right? So whenever I've got my unit circle, the unit circle, the radius is always 1. So here at 0 degrees I'm at 1, 0. At 90 degrees I'm at 0, 1. At 180 degrees I'm at negative 1, 0. At 270 degrees I'm at 0, negative 1. The radius of the circle is 1. So the hypotenuse here is always going to be 1. So that means sine of the angle is always equal to opposite. And let's talk about cosine. So if I've got a coordinate here, the y value is simply this opposite side, right? From this angle, the y value is this opposite side. So the y value is going to be sine theta. So it's going to work the same way with cosine. Cosine theta is equal to adjacent over hypotenuse, right? Now if the hypotenuse is 1, then we know cosine theta is equal to the adjacent side over 1. So I could say that this value here is the adjacent side, and the adjacent side is x. So if I've got this angle here, I'm going to change it to theta. If I've got this angle here, the x direction is going to be, why did I write x there? The x direction is going to be cosine theta. So I go over x direction, I go up y. So I go over cosine x, and I go up sine theta. Okay, so we're going to come back to this in just a minute. Okay, so once again, on the unit circle, at 90 degrees, we're at pi over 2. At 180 degrees, we're at pi. And at 270 degrees, we're at 3 pi over 2. Okay, and I've plotted those points on the circle. Where might you find 225 degrees? So all the way to here is pi, so 225 is out a little bit more, because 90 is up here, 90 degrees, 180 degrees, and this is going to be 270 degrees. So 225 is halfway between there and there. Exactly halfway between there and there. Okay, 360 all the way around the circle. 3 pi. That means I've gone all the way around the circle, because from here to here is pi, from here to here is 2 pi, 3 pi is around another, and you end up right here. Okay, negative pi over 2 means we're starting here, and I'm going to go this direction. So negative pi over 2 means I'm going to go clockwise instead of counterclockwise. And I end up here, which is equivalent to 3 pi over 2. Negative 45 degrees is halfway, so like negative 90 would be to here, so negative 45 would be to there. And negative 400 would be all the way around 360 clockwise, and then over a little bit more. Okay, next page. Okay, so from the unit circle, explain why cosine theta is equal to x and sine theta is equal to y. So as I mentioned before, if I go to some random place on the circle, I've got theta degrees. So in the x direction, I'm going cosine x. In the y direction, I'm going up. So this is why a normal coordinate here on the circle is x comma y, and since we said the hypotenuse is 1, it's going to be cosine theta sine theta. I labeled this the quadrants 1, 2, 3, 4. It doesn't say to do that, but I think it's super important for you to know. Whenever you're in quadrant 1, the sign of the cosine x, the symbol is going to be plus and plus. When you're here, the x value or the cosine value is always going to be negative, and the y value will be positive in quadrant 2. Quadrant 3, cosine and sine values will always be negative, and in quadrant 4, cosine values and sine values will be positive and then negative. Okay, and that'll come into play when we do some more problems. Okay, now you've learned from SOHCAHTOA that tangent is opposite over adjacent. Now, we just said on the unit circle that opposite is, we said that the opposite is sine x. So I'm going to replace the opposite with sine x. And we said the adjacent side is cosine x, so I'm going to replace the adjacent with cosine x. Okay, and so here we've given tangent theta in terms of sine theta and cosine theta. Okay, let's change that to a theta. Okay. The results of the question extend positive and negative. Okay. So when it's saying the results are positive and negative, the domain for x is between 1 and negative 1, right? And the y value, the range is between positive 1 and negative 1. So I added this here. I think it's important. So our domain for the x values is between negative 1 and 1. The range for the y values on the unit circle is between negative 1 and 1. Okay, I think you should add this to your notes here. Okay, so if the angle is negative, then we're going to move clockwise on the circle like I showed you on the previous page. So and if the angle was positive, as you know, on the unit circle we go counterclockwise if it's positive. So if we're going negative angle, then we're going to go clockwise. Okay. So negative angle represents a clockwise rotation. Okay. So, and I just proved tangent theta is sine cosine, sine angle, the sine of the angle divided by cosine of the angle. Okay. So I've already filled this out, but I want to talk about it from the unit circle. So sine of negative 90. So if I go from here, I go down to negative 90. Sine, as we said, was the y value, and the y value is negative 1. So that's where I get that value. 0 degrees, the sine value is 1. So we get that. At 90 degrees, the sine value is 1. At 180 degrees, the sine value is 0. At 270 degrees, the sine value is negative 1. At 360, we're back to where we started, at 0. 450 degrees, that's 360 plus 90. That brings me back up here. We're at 1. Okay. Cosine works the same way. Cosine is the x value. So at 0 degrees, we're at 1. Right? Okay, at negative 90, it means we're going clockwise over here, and the x value here is 0. At 90 degrees, we go counterclockwise, and our x value is 0. I'll put in 0 here. At 180, I go counterclockwise halfway around the circle. We're at negative 1. And I hope you get the idea. Okay, so last year in SL class, we learned how to make our sine waves and cosine waves. Okay, and you may notice the cosine wave is just like the sine wave, except it's shifted over, and that's going to be important this year. Okay, so how do we describe the sine function beyond the first quadrant? So basically, beyond the first quadrant, each of these pieces here is just like the other. This is a reflection over here. This is a rotation. This is another rotation, and that's going to be important when we start talking about topics later in this semester. Okay, so it's a reflection and a rotation. Okay, how do we describe cosine functions beyond the first quadrant? Same sort of thing. It's a reflection and rotations of quadrant 1. Okay, draw a graph of sine x on your calculator. So super important when you're using your calculator that your window is going to have to be different in order to see your graphs. If you don't have the window correct, you're not going to see it. So if you're in degree mode, the x max has to be 360. Okay, so if I'm in degree mode, so I go to mode, I go down here, degree, I hit enter, and we're trying to graph sine x. Sine x. Okay, and you already know what this looks like. But the critical thing is the x max has to be 360. If I'm going to do this in radian mode, then my window, the x max has to be 2 pi. So I'm going to do second, and the caret here gets me pi. Oh, and it's times 2, right? Okay, enter. So 2 pi is 6.28, blah, blah, blah. And then if I graph that, oh, what did I do? Something wrong. Oh, duh. I didn't change the mode. All right. Radian mode. Okay. So, as I said before, the window for degree mode has to go from 0 to 360 to get one period. The window in radian you have to change the x max to 2 pi. So that's super important. If you're going to make a mistake like I just did, you got to be able to troubleshoot this. Okay, so with your graphing display calculator, what happens when you type in sine x squared plus cosine x squared? You're going to get a horizontal line, y equals 1. So I'm going to type that in right now. Sine x. So I have to close the parentheses and then square it plus cosine x, close the parentheses, square it, and it's going to draw a horizontal line at 1. So why is this happening? So the thing is, you've all heard of Pythagorean theorem. A squared plus b squared equals 1. Now, so here's my triangle, and let's just call it a right triangle, right? So if this leg is sine, and if this leg is cosine, and if the hypotenuse is 1, then I can use Pythagorean theorem to say, a squared plus b squared equals c squared. So I could say sine squared theta plus cosine squared theta is going to be equal to 1. And that's where that formula comes from. Ooh. You don't need to memorize it because it will be on your IB formula sheet. So, so here's the formulas we've come up with so far. And since cosine, so explain on the unit circle why cosine negative theta is equal to cosine theta. So let's look at my unit circle. We just said cosine is the x values, right? So if I go up 30 degrees, I'm at square root of 3 over 2. If I go negative 30 degrees, I'm down here. Oh, I'm also at square root of 3 over 2. What if I go to 60 degrees? I'm at 1/2. What if I go negative 60 degrees? That's going to take me about down here. And I'm at 1/2 also. So on the unit circle, I've just shown you that negative cosine theta. So if I go, it's going to give me the same value as cosine theta. So if I go a certain number of degrees up, I'm going to get the same x value as I go a certain number of degrees, the same certain number of degrees down. Okay. Find an expression for negative sine theta. Now, sine theta is the y values. So if I go up 1/2, if I go up 30 degrees, my sine value is 1/2. The y value is 1/2. If I go down 30 degrees, my y value, the sine value, is at negative 1/2. So basically what we're saying here, and same thing here, if I go up 60 degrees, my y value, the sine value, is radical 3 over 2. If I go negative 60 degrees, my y value, the sine value, is at negative radical 3 over 2. So basically what we've just said here is if I go negative sine over x, like instead of if I go 30, I'm at 1/2. If I go negative 30 degrees, I'm at negative 1/2. So I'm going to have this negative value. I'm going to get the result, but with a negative. Okay, and in cosine, if I go up a certain number of degrees, I'm going to get the same value as if I go that way. Okay, so to do this next example here, use your graphing display calculator. Okay, so I'll show you the first one here. So I've got y equals sine x, okay, and then y equals 1/2, 0.5. Okay, so I've written these two equations, y equals sine x and y equals 1/2, and then if I graph them, we want to find out all the values of x. So basically, to find the values of x, I'm going to have to hit second trace, and then down 5 to intersect, and then I am going to move. We're going to have two answers. So I'm moving this x close to the intersection, and then I hit enter. Enter again. It says guess. I hit enter again, and it tells me that intersection is 0.523. 0.523. And I do the same process again. Second trace, 5 for intersect, arrow closer over to it. There it is. Enter, 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 and I get the same answer, 2.61. Okay, you do the same process again, except cosine x, negative 0.2, and you should check this answer. Hit pause if you need to check. Okay, next. Okay, use your triangle shown to find the exact expression for sine 45. Okay, so if I want to find sine of 45, I can get my circle. Sine, as we know, is the y value, and the y value is going to get me radical 2 over 2. Okay, cosine of 45 is going to give me the x value, and we know the x value is radical 2 over 2. Okay, hence write down the exact value of sine 45. So sine of negative 45, I'm going to go down this way, and sine of negative 45 is the y value, so negative radical 2 over 2. And cosine of negative 45, I go down 45 degrees in the clockwise direction, and I'm going to be at radical 2 over 2. And just for kicks, I want to show you, I'm just going to type in sine 45 just for fun. Sine 45 degrees. Oh, wait. We're going to do this in radians. Here. Cosine negative pi divided by 2. Oh, divided by 4. And I get 0.707, right? And just for fun, what is the square root of 2 divided by 2? And I bet you we're going to get 0.707. So I was able to figure out these values of sine and cosine without using the calculator. So this is called exact values for these angles. And that may be useful when you take higher level math. Okay, so use your knowledge of the unit circle to find these values. So I can do all of these without a calculator. Oh my goodness. So sine of 0, I go to 0 degrees, sine is the y value, I'm going to get 0. Okay, cosine 0 is the x value at 0 degrees, and we get a value of 1. Sine of pi, I go to my unit circle, I go to pi, sine is the y value, I get 0. I hope you're starting to see the pattern here. Cosine of pi over 2, cosine is the x value, pi over 2, we're at 0. Sine of negative pi over 2, negative pi over 2, I'm going clockwise down to here, and sine is the y value, I'm at negative 1. Okay, cosine of negative pi. So negative pi is the same thing as going pi, right? So cosine is the x value, and oh, did I mess that up? Cosine is the x value, and I should be at negative 1. That's a mistake. Negative 1. Yeah. Okay. Sine of 3 pi over 2. 3 pi over 2. Sine is negative 1. Yep. Cosine negative pi over 2. Negative pi over 2. I'm going down this way. Cosine is the x value. It should be 0. Okay. So, if we find the solutions, so basically what I did here is I typed into the calculator y equals sine x and y equals sine so sine x equals sine 2 pi over 5. So sine x, and I did sine 2 pi divided by 5. Okay, now we've got to make sure we got the window. It says from 0 to 3 pi. So I go to window, I change this to 3 pi, and then I can graph. And then I can figure out the intersections just like we did on the previous problem, and there are 4 intersections. Okay. When is cosine x equal to 0? I don't even need a calculator for that one. I can just look at my unit circle. Cosine is the x values. It happens at pi over 2, 3 pi over 2, and once again at 5 pi over 2. Okay. I'm going to skip number 5 and explain that later. But the thing you need to know, so we start off with, we got triangle PQR, angle P is 25 degrees. Line PQ is 7, and line QR is 5. And the thing is, this is an angle side-side situation, so the pink side could either be out like this, if this is 25 degrees, or the pink side could be in this way, and we could figure out our lengths here with that situation. But I'll explain that in a different problem, different video. Okay. So use your equilateral triangle to find exact values. So sine 60, so sine, as we know, is the opposite side. So we already know that the opposite side of 60 degrees is radical 3 over 2. Okay. Cosine of 60. Cosine of 60 is 1/2. That's what we have here. Sine of 30. Sine of 30 is 1/2. And cosine of 30 is radical 3 over 2. Okay. Hence, find the exact value of cosine negative 60. Negative 60 brings me down to this pink line right here. And what are we finding? Negative cosine is the x value, which is 1/2. Positive 1/2. Sine of pi over 6. Pi over 6 takes me to 30 degrees. Sine, it's going to be 1/2. Cosine of negative pi over 6. Negative pi over 6 takes me down to here. And we said, what did we say? Cosine is x value, radical 3 over 2. Okay. So I'm going to leave this here for you to see and check your answers. Same process each time. Okay. And there we go. Hope that helps.